Here in this video, we would like to talk about series grouping of cells. Cell is a kind of a source which generates a certain kind of EMF. This is a cell having some EMF E. But each cell also will have some kind of an internal resistance. Only ideal cells will have that value 0, but we assume that these cells are having some internal resistance. If I connect another identical cell like this kind of a connection is called a series connection. So let's assume there are so many cells, say for example n number of the cells, n cells connected in series. They are all connected to a external resistance R, capital R. What is the current in the circuit is my first point I would like to discuss. The current in the circuit is total EMF by total resistance. When the cells are connected this way, this kind of a connection is called a series connection. Current flows in the same way because negative plate is connected to positive and a negative plate is connected to positive, negative plate is connected to positive, and so on. This kind of a connection is called as a series connection. In series, EMF get added. Therefore, the total potential difference, the total EMF is EMF of one cell is E, but there are n number of the cells like this. So the total EMF is nothing but equal to NE. What is the total resistance is? That's also the point that we need to find out. Total resistance. As I said, internal resistance acts like a series resistance. So this is one series resistance, this is one series resistance, this is another series resistance. And the current is further passing this way to this external resistance and coming back to the batteries. That means all these resistors in the circuit are connected in series. So the total internal resistance is, each cell is having a resistance R. There are n number of the cells. N number of the cells in series is NR, because in series resistance gets added up, plus external resistance capital R. This is the total resistance. So we can use the Ohm's law. V equal to IR. So the current in the circuit is total V, that is NE, by total resistance, this value. Number of the cells multiplied by the internal resistance of each cell in addition to the external resistance of the circuit. This is the total current we can draw from the circuit. So the point that we would like to identify is, when this kind of a series resistance helps, it helps if the external resistance that we have connected is much bigger than that of the sum of the grouping of the internal resistors. If that is the case, I can ignore NR in this equation. Then because capital R is much greater, I will become NE. I'm ignoring this NR, this value, by capital R. So the total current will become number of the cells multiplied by the EMF of each cell divided by external resistance. You might be thinking, what happens if that's not the case, if that's the other case? That is, if NR, that is internal resistance together, is much bigger than the external resistance of a circuit. Now this capital R has to be ignored because this NR is much larger. Then your I will become NE by, I ignore this capital R, I write this NR now, N into small r, N and N will get cancelled. So the current generated in this circuit is EMF of one battery by internal resistance, that is equal to the EMF of only, that is equal to the current generated across only one battery. That means though you connect n number of the cells, you get a current value that is very small, that is E by R, which is not at all suggestible. This is suggestible. So when we can prefer series grouping is, we can say we shall prefer series grouping only in this case, right? When internal resistance is smaller together than the external resistance, series grouping of cells is preferable. Series grouping is preferable. Otherwise, it's not preferable. We shall go for a parallel grouping that we will discuss in the next video. Now we will talk about what happens if I connect certain cells wrongly. If, say for example, one cell gets wrongly connected, What do you mean by wrongly connected is, instead of this way of connecting negative to positive, if it is connected in reverse like this kind of a connection is called reverse connection. If one cell is wrongly connected or reversely connected, the total EMF becomes, say for example, so this becomes plus E, this becomes a minus E, this again becomes a plus E. Therefore, if once, say for example, I will connect some 4 cells, 1, 2, 3, 4 cells, each one having EMF E and internal resistance are connected in series. The total to an external resistance capital R. Now the total EMF will become E plus E plus E plus E, 4E. But say for example, now I have connected one cell wrongly. So when one cell is reverse connected, what is the diagram that you can draw? Cell 1, cell 2. But be careful, notice this. Cell 3 I have connected in reverse. Be careful, notice this. This I have connected in reverse to the same circuit like this. Now this is plus E, this is plus E, this becomes a minus E because it's connected in reverse. This is again plus E. So what's the total EMF is? E total in this case is plus E, minus E, plus E. Remember, one E cancels other E. It doesn't becomes 3E, but it becomes only 2E. So be careful. When one cell is connected in reverse, it affects one more cell so that the EMF reduced is the double to the number of the wrongly connected cells. So if somebody say, if M cells are reverse connected, what happens to the total current in the circuit is I is, if all of them are connected correctly, it could have been NE, but M cells are connected wrongly. Each one wrongly connected cell reverse one more cell like this. Therefore, minus 2ME has to be written. By the resistance is not going to vary whether you connect it in wrongly or rightly. Resistance always adds up. So this will be the formula for the what we have to say when if you connect M cells wrongly. So N minus 2M where M cells are connected wrongly and N is the total number of the cells. This is the total current in the circuit. This is how we have to calculate if one cell is connected wrongly or one cell is connected in reverse. Now, is it okay to be connected wrongly in every case? No, right? If number of the cells is greater than 2M, it's okay. You will get some kind of a positive current that is flowing in the circuit. What happens? You will get some I. If number of the cells is equal to 2M, see, look at this term. N and 2M becomes equal, so the numerator becomes 0. 0 by anything is equal to 0. So the current becomes 0. What if 2M is greater than N? That means what? There is more reverse current than the regular current, therefore I gets reversed. So this is not at all a suggestible idea. This is only a suggestible idea. So even if you have connected wrongly, the circuit works only when the number of the cells is more than the double the wrongly connected cells. Then you will get some current in the circuit. Otherwise you won't get anything. That's it. Thank you.